Good morning everyone, I am Sanjeev Sharma. Today I am going to talk about emulsions. Emulsions are one of the common format of material which we see around us, whether it is cosmetics or in food. So to understand emulsion, we have to understand its phases, continuous phase, dispersed phase, and we have to understand emulsifier. So let me start with a basic question, what are emulsions? So emulsions are the stable mixture of two immiscible components. For example, if you try to mix oil and water without any additive, it will separate out. But on the other hand, if we see butter, cream or mayonnaise, they are nothing but they are the homogeneous and stable mixture of oil and water only. So these are the emulsions, and oil and water are the different phases. Now let us understand what are phases. As the term implies, the dispersed phase are those phases or those components which has to be dispersed or which has to be distributed uniformly in the bigger mass which forms the continuous phase. Next question arises, when we mix two components, which one will become continuous phase and which one will become the dispersed phase? A common theory is that the phase which is in higher quantity will become the continuous phase. For example, if we try to mix 20 ml of water and 80 ml of oil, oil being in the bigger quantity will become the continuous phase. Let us take an example. Both butter and mayonnaise have 80% oil in it, but the butter is water in oil emulsion and mayonnaise is oil in water emulsion. Though in mayonnaise fat is at 80%, but it is not a continuous phase. So the actual theory is the phase in which the emulsifiers are soluble becomes the continuous phase. So let us take example of eggless mayonnaise. In eggless mayonnaise, if we have 80% of oil, we add milk powder as the emulsifier. As milk powder are soluble in water, the water, though it is only 20%, becomes the continuous phase. Now let us understand emulsifiers. Emulsifiers are the chemicals or food additives which stabilizes an emulsion. Structure wise, it has two components, one is lipophilic, another is hydrophilic. One phase is has more affinity for water, another has more affinity for fat. And based on the ratio of these two, the functionality of emulsifier is decided. And technically we call it HLB value, hydrophilic lipophilic balance, or in a common language, the ratio between hydrophilic and lipophilic component in the emulsifier. And the question arises how it balances, how it stabilizes an emulsifier. So as I said, the ratio of them decides its functionality. So if an emulsifier has higher HLV value, it means it has more hydrophilic component, it means it is more soluble in water. So always a higher HLV value emulsifier will make oil in water emulsion because it is soluble in water and water will become the continuous phase. And how it stabilizes an emulsifier? To understand it, let us consider that we want to make oil in water emulsion. When we mix them without any additive and apply a mechanical energy through agitation, each and every components are broken down into small droplets and it is distributed uniformly. But the moment we take out the mechanical energy and allow them to settle down, both the droplets come together to form a big droplets. Two big droplets come together, they merge together, they form bigger droplets, and eventually both the phases are separated out. But when we add emulsifier, through agitation, the emulsifier are well distributed in the continuous phase, and the lipophilic portion of the emulsifier, they come and stuck on that surface of the droplets of fat, and it covers it and forms a boundary, and the hydrophilic portion keeps on dangling on the surface, which is exposed to the continuous phase. Now two droplets of oil covered with same emulsifier, when they try to come together, there is a repulsive force. They cannot merge together, they cannot make a bigger droplets, and they cannot separate out. So this is the fundamental understanding and the science of stabilization of an emulsifier. Thanks for your time.